and share the agenda. And this is the agenda for this week. How's everyone doing? I hope you had a good long weekend.
Yeah, it was good. It was, we got out of town and saw some family, so.
Nice, yeah, that's great. It's Tuesday, but it feels like Monday, doesn't it?
Yeah, it was kind of, the entire weekend was off because we got in Friday night late, and then Saturday, my wife's dad had the day off, which he normally works, so then everything just felt like, when we got to Sunday, we felt like it was Saturday. And
yeah, I think this whole week we're going to be a day off. All right, it's 10 o'clock, everyone. Let's go ahead and get started. And welcome back to week 8, believe it or not. So this is getting close to the end of the spring quarter. So this is the agenda for today. And I think by now we all know that the Net Academy exam answers, final exam answers, SBA, labs, all these answers are in the internet. I don't think anyone out there doesn't know this. However, there's this thing called integrity, and there's this thing called, I want to learn and I want to do it myself. And I've always expected a level of lack of integrity, but it's getting a bit excessive. So I feel like I need to talk about it one more time really quickly. So it is definitely okay to Google and YouTube to learn. And I do it all the time, every day I do this. And that is okay. And it's even okay to go and look at someone else's lab and someone else's work. That's fine, as long as the intention is to learn. Okay. It's not okay to copy. So just to download, an assignment or an SBA and make a couple of tweaks and upload it, that is just not okay. And I know you know that. And for those people that do it, they know it's not okay. And if you're doing this, I would love for you to take a minute and ask yourself, what are you doing at LBCC? What did you sign up to go to LBCC for? And I'm confident way at the top of that list, it's to acquire the skills that you need for a future job. And by copying and by downloading and by making a few tweaks, you're cheating yourself. You're cheating, period. And B, most important, is you're cheating yourself. You're cheating yourself from an education. You're cheating yourself from a wonderful career down the road. So that's all I wanted to say. And I will be taking a closer look moving forward. And sometimes it's quite obvious, what is downloadable material, and I will act accordingly. So just FYI. So what is left for this quarter? This is week 8. So this week, week 8, we're going to go over chapter 9, which is ASA. Really important. Super common, super popular security appliance. And I think this is the last chapter, everybody. This is the last chapter where we have serious technical material to go over. Because the next chapter, chapter 10, is ASDM. And ASDM is the GUI for the ASA. So this week, we're going to learn how to use the ASA CLI. And if you, by now, if you know how to use the command line interface, the GUI is a piece of cake. And this is really what chapter 10 is. Chapter 10 is the GUI for the ASA. And Packet Tracer doesn't support it, so we can't use it even if we wanted to. And I don't think we're missing much. And then chapter 11, we're just wrapping up. I don't think there's a whole lot of technical material. It's important, but there isn't a whole lot of technical material. And it's just, a wrapper for the entire security course. So this is the last chapter where we'll be learning new technical material. And then week 10 is finals week. We don't have week 11 this time. And Tuesday, June 9, we're doing the SBA. And I'm going to place the file that I'm creating as we speak on Net Academy, and I will show you where, and you will have from 10 till 1. So you'll have 3 hours, which I believe is ample time to do the SBA. And then you upload it into Net Academy, and I will grade it from there. And then Thursday, June 11, it's the final exam. Cisco says 70 minutes. I'm giving you 120 minutes. So I think you'll have ample time to take care of the final exam. And then I will do the grading, and this is it for the quarter.
Hey,
so go ahead.
Is there a practice SBA out there?
I can make one available, and
Okay.
I believe the answer is yes. There are some practice ones, and let me show you. Stay with me for 1 second, okay? I believe the chapter 11 they have an excellent practice SBA. So let me show you. So I'm going to go. So this is where we are, everybody. ASA. Next chapter is the ASDM. SDM is the Cisco GUI tool to configure routers and switches, and ASDM is the ASA SDM. And if I was to go to assignments, and if I was to go to chapter 10 and 11, and you see this 11.3.1.1, everybody, this is an excellent preparation for the SBA. So this is what that is. So take it seriously, and I think if it makes sense, 11.3.1.1, I think you'll have an easier time with the SBA. And that's it. That's the only thing you need to do for chapter 10 and 11. This one assignment is quite large, but it's one assignment. So as far as where will I place the file, so you can see in the navigation panes, we have a files link. And this is where I've been putting the Zoom links. Some of you have been using it. And just below it, there is 1-SBA. And this is where the SBA file will be placed on Tuesday before 10 o'clock of week 10. Questions? All right, so let's go ahead and jump into it. And we're done with this. And today we're gonna do labs 2, 3, and 4. And we're gonna get all the way to the objects in the slides, and then we'll leave the rest for Thursday. So let's open the slides and talk about the ASA. Here we go. ASA, which stands for Adaptive Security Appliance, and security appliance is a device that was designed specifically for security. And up until now, every time we talked about security, we talked about layered security. And I know you remember that. And we said, you need a firewall to protect you from the outside. And then we talked about intrusion prevention. We talked about advanced malware. We talked about the importance of single-factor, multi-factor authentication. We talked about logging. And then we talked about securing the local area network with port security, trusted ports, untrusted ports, the binding table, all that stuff. And we can't possibly take all of this and put it into a single device. However, Cisco wanted to develop, and not just Cisco, but Cisco is the 800-pound gorilla in the networking field. They decided they needed to develop a product that encompasses many of those security features, security appliance. So they came up with this ASA, and it includes an advanced firewall. It includes advanced IPS. It includes advanced anti-malware and a bunch of other related security features, all built into this fairly small device. And it's super popular. ASA devices are very, very popular. I can't tell you how many data centers I have walked into, and boom, I look at the router that connects the enterprise to the internet, and right behind that router, they have an ASA device for a good reason, because it's one device that does all these different things for you. And Cisco has many ASA devices to scale, from a tiny company, even from a home office, all the way to an enterprise. And if you were to look to the right-hand side, you can see up to 150 megabit per second, up to 750 megabit per second, up to 1 gigabit per second. So what do you need? And they have a product that is going to work for you, because you don't want, this is an inline device, everybody. So usually it doesn't have to be used inline, but almost always it's used inline, meaning, it's a sitting on the wire, and you don't want it to become the bottleneck, because it can easily become the bottleneck if it's doing too many things, and if it's a low-end device and you have a heavy traffic, so it can become a bottleneck, and that wouldn't be a good thing. And if we were to go to the next slide or two, you can see, you know, it scales all the way into the gigabits per second for a large enterprise. Good, everybody? So all of these are different flavors of an ASA, and way at the low end is 5505, 5506. And those are fairly small, inexpensive devices, inexpensive as in a few $100s. And then you can buy additional features for that device, and it will add up. So this is not something you want to have inside your home, not that you can't. It's just a little bit expensive, and if you're an enterprise and you have 10,000 people working from the home, you know, it's gonna add up. And before you know, because this is what I hear all the time, can I get one for my house? And it's like, great, yes, of course you can get one for your house. However, at some point you're gonna take your laptop and go to a coffee shop, or you're gonna go to a friend's house or your parents' house, and you wanna be able to VPN from there. And you're not gonna be able to take that ASA device with you. So it's not really designed for a single user, but you know, for a small branch office, for a home with multiple people working from there, it would be a good fit for that. Okay, and you can see some of the modules that you can purchase for these ASA devices to do IPS, to do advanced malware, etc. Any questions on what ASA is? Adaptive Security Appliance. It's an appliance that is designed specifically for security and includes several of the security features everyone is interested in, except instead of having them in different devices, we want to bundle all of them into a single device. We're good? Okay, moving on. So ASA virtualization. So you can imagine, you know, you have customer A, customer B, customer C, and if you want to VPN between you and your customers, or between different branches of the same company or a sales office, etc. So you want to do it over the internet. And we covered this last week. You know, VPN is king. This is how everyone connects everywhere these days, with VPN, because the internet is mature, the internet is fast, the internet is reliable, the internet is there cheap. And this is by far and everybody is connected to the internet, and we can use that connection everyone is already paying for VPNing, and we do that. And ASA also provides that service. So it's a firewall, it's an intrusion prevention, it's an advanced malware, and we can VPN into it, site to site or individual to a site. And we talked about those two flavors last week when we talked about IPsec, and we will come back to IPsec because of course ASA supports IPsec, and of course we want to use IPsec to VPN wherever we want to VPN. Okay. And here they are telling us, you know, because it is a device that is sitting in line, you don't really want to be dependent on this one device. What if it goes down? It's a piece of hardware, and you know, it's gonna fail at some point, and you don't want your enterprise internet connection to go down, so you can have redundancy. This is all the slide is telling you. And I'm sure you remember HSRP, or maybe I need to refresh your memory, Hot Standby Routing Protocol. This is the routing protocol that we can use to have redundancy on layer 3. So you're not just dependent on one router, that if a router fails, you can use another router. It's basically the same technology we're using here with ASA. Okay. And yes, it is a firewall. That is one of the very important security features that ASA provides, not just a firewall, but an advanced firewall. And it's basically saying that if you want, you can connect it to a directory service like Active Directory. And we've been saying since CS240A that Active Directory is the default directory service on planet Earth. It's excellent. It's built into the Windows products, and everybody wants to communicate with it because nobody wants to replicate those services. Just talk to Active Directory and go from there. Okay. So the SSM are those modules that you purchase. For example, if you want intrusion prevention, if you want advanced malware, and it's not built into the product, you can purchase a module that you plug, because you don't really want the ASA CPU to be doing all this work. If you want the ASA CPU to be doing all the work, then it's going to become a bottleneck. So you want to outsource as much of it as you can. And these modules are like a microcomputer that were designed specifically for a single purpose, and they will take some of the load off the main CPU. And we're getting to ASA some details. Any questions so far? I went over the first few slides quickly because there isn't really very much there. It's just a high-level introduction to ASAs. All right. So this is a very, very typical use for an ASA. Remember, an ASA is sitting between you and the internet. So of course you have the inside, okay? And we have the outside, which is the internet. And if you want, you can have a DMZ. So these are, and the inside, we'll talk about that in a short while here. You can divide into different areas. So it doesn't have to be all of the inside. It can be R&D inside. It can be finance inside. It can be something else, manufacturing inside. But definitely you have an inside, and we have an outside, which is the internet, and we have a DMZ. And by default, everybody by default, from the inside, you can go to the internet, and from the inside, you can go to the DMZ. And by default, this arrow between the internet and the DMZ is incorrect. Everyone, it should be the other way around. By default, you can go from the DMZ to the internet. And if you want to, you can create ACLs to do whatever the heck you want. So when I say by default, I mean, if you don't really do any ACL configurations, this is how it's going to work. But if you want traffic to flow in a different direction, absolutely. Okay, it's just a router, and you're the administrator, and you can do whatever you want, and you can create ACLs to allow whatever traffic to go in whichever direction you want. Okay, and what this is saying down here, the night traffic, is we don't really want by default internet traffic to come into the inside, and by default DMZ traffic to come into the inside, which is terribly, terribly unusual these days, because we want people to be able to access our internal resources from the outside. So we have to drill holes into the firewall to allow some. Of course, we don't want all internet, we don't want all DMZ, but we want some traffic to go through the firewall into the inside. But this is just default configuration. You take the ASA out of the box, and you just do basic configuration, and this is how it's going to work.
Okay. Zico?
Yes.
So how does this combine with the Microsoft server as far as security wise? I mean, you have a.
Okay. So did I hear you correctly? You're talking about Microsoft server?
Yeah, because as far as a user security, firewall and stuff. I mean,
so remember, this is a device. Camping. This is a device that's going to be sitting between your enterprise and the internet.
Okay.
Okay. And then way inside your enterprise, you have your servers, right? Yes. And we know Windows Server has a very good firewall, and you most certainly want to be using anti-malware. And if you want, you can also have an intrusion prevention system in your server. So there's nothing wrong, with having those services at multiple layers, intrusion prevention and firewall and anti-malware. But connecting your enterprise to the internet is a router. So you have a router that connects you to the ISP. And immediately behind that router, you have an ASA device. And that ASA device is scanning everything that is coming in. So whatever is coming in or exiting, but mostly you're interested in what's coming in. So you're scanning and you're determining, do I allow this piece of data in? Yes, no. Based on ACL, based on intrusion prevention, based on advanced malware, etc. Okay. Did I answer your question?
Yeah, it just, I'm trying to look at the picture of combining the two. Yeah, just thinking of that, that's all.
So when you design your security policy, you know, you want to say, okay, what do I do at the demarcation point? And this is really where ASA lives. It lives at the demarcation point. And then what do I want to do in the individual devices?
Okay.
And what do I want to do at the router interface? Because a router is also a firewall. And how do you want to filter traffic among your different local area networks? If you have an R&D local area network, if you have a finance local area network, you may want to protect those from inside traffic, even though it's all inside. Okay.
Okay, thank you.
You are most welcome. So as far as the modes of operation, you can use it as a router, which is what most people do. This is, you know, the default usage for an ASA. It's a router that's sitting behind the other router that connects you to the internet, or it can be that router that connects you to the internet. Depends on how many layers of security do you want to have. But usually enterprises have a router, a dedicated router that connects them to the ISP, and then they have an ASA device that sits behind that router. And the reason why you have two is because you don't want to put all the load on that one router. So you say, okay, you know, your job is just to connect me to the ISP, and immediately behind that router, you have a security appliance like an ASA that is taking care of the security for your enterprise without putting too much load on that one router. If you're a poor enterprise, maybe all you have is just an ASA device, and your ASA device connects you to your ISP and does everything else. And transparent mode, basically you're saying, I'm not really routing, I'm just using it for those security purposes. I'm not using it as a firewall. I'm not using it as a router. I just want to check for intrusion prevention. I want to check for malware, etc., etc. And this is called a bump in the wire. The transparent mode is called a bump in the wire. Licensing, it has a unique and a different licensing, everybody, and based or depending on what you want, you know, you may require a different license. And I really don't like to get into licensing because it's a very large, complex topic and it's non-technical. But, you know, you have to make sure that you have the proper licensing for your ASA device to support what you need to do. Very good. So at the very lowest end, we have ASA 5505 and we have ASA 5506. And they are showing us the front side and the back side of ASA 5505. And this is a super common appliance. You have to remember the vast majority of companies here in the United States are small. And you know, they don't really have the money or the resources to do anything fancy, and this is fairly basic and expensive and a pretty good security appliance. And then if you were to look in the back, and this is the part I'm really interested in, is we have 8 ports. And you can connect whatever you want to these 8 different ports. And they're showing you these 2 ports combined if you want to use power over Ethernet. So you don't have to have a separate power cable for your ASA device. You can use power over Ethernet, and because it's an appliance that requires a little bit more electricity, you will need 2 Ethernet cables to provide power to it. Okay. Security levels. Okay, this is really where it becomes very interesting, everybody. ASA supports security levels, and those security levels are super important, and I want you to pay attention because we need to get our brains around those security levels. Okay, so we go back to inside, outside, and DMZ. And please remember, inside can be several different zones, all inside. But at this high level, we're basically saying that first you have to name the interface. So we're saying the interface name is outside, the interface name is inside, the interface name is DMZ. So you don't have a choice there, you have to name it. And then we're assigning it a security level. And this is how it works. You can go from higher to lower, no problem. You can't go from lower to higher without an ACL. So by default, you know, A higher can go to lower. You don't really need any special permissions. However, to go from lower to higher, you will need an ACL. Otherwise, by default, ASA is going to stop it. So if you were to look at the inside, it is 100. This is the highest. If you were to look at the outside, it's 0. It is the lowest, and DMZ is smack in the middle. It's 50, which means we can go from 100 to 50 and 0. We can go from 50 to 0, no problem. And then to go from 0 to 50 or from 0 to 100, we will have to depend on ACLs. And of course, we'll do labs to do this later on. But remember, 0 to 100, you have a lot of granularity, meaning that if you want inside, it doesn't have to be all 100. You can have R&D at 90, you can have finance at 80, you can have manufacturing at 70. And now by default, you're putting some barriers between the different areas in the inside. So you're saying R&D can go anywhere, but we don't want anyone to come into R&D. Finance can go to manufacturing, but finance can go to R&D because their security level is 80, R&D is 90, and manufacturing is 70. Does that make sense, everybody? So that's built in. All you really have to do to enable that firewall to work properly for you is to assign these different areas a different security level, or it can all be 100, and then you can rely on ACLs to protect R&D and finance. Someone has a question.
Is that similar to a VLAN setup?
Is it similar to VLAN?
Yeah, because you set up different.
So you can associate these different security levels with different VLANs.
Okay.
Okay, so R&D is one VLAN, finance is a different VLAN, and manufacturing is a different VLAN, and then you can associate a security level with each of these VLANs.
Oh, okay.
So let's remember those security levels, everybody. And please remember, just because by default you can go from lower to higher, it doesn't mean you can't create an ACL. Of course, you have to allow some traffic from the outside in. Of course, you have to allow some traffic from DMZ in. But now you are dependent on ACLs to do that. So ASA 5505 deployment scenarios, small business. Okay, so that's all you have. You have a small business. And remember, the vast majority of companies in the United States are small businesses. And that's it. They just have a single ASA device that connects them to the internet, to the outside. And then remember, we have 8 Ethernet interfaces. And usually that is enough. Or if you want, you can put a switch behind one of those interfaces, and now you can support a larger number of devices. But if all you have is a handful of devices, ASA is all you need. You don't really need additional networking devices. You have this one device, and it does it all for you. And this is why it's so nice, because this one single device that does it all for you, and it's easier to purchase, maintain, etc. Okay, and then for a small branch, and I don't know what small branch means. For me, a small branch is 100, 200 people, and a single ASA device is not going to do it for you. You're going to need additional devices like switches, and then you can connect the end devices to those switches and the switches to the ASA device. So for the small branch, we have a DMZ, and for the small business, we don't have a DMZ. So that's the big difference. Here we have 2 zones, inside, outside, and for a small branch, we have 3 zones, inside, outside, and a DMZ. Okay. So here they are showing us IPsec VPN, and this is a very, very popular use for ASA. So you can VPN. So site-to-site VPN, just like we saw last week, and you will see this week, or just a remote user VPNing into the company. You're working from a home, you're working from a coffee shop, and you have an IPsec client, like a Cisco Connect, AnyConnect, or like the product that is built into the Windows platform. And then you can VPN into an ASA device. and that ASA device is capable of hosting multiple VPNs. So that single ASA device can have multiple VPNs into other sites and support a bunch of remote users at the same time. And that's a common use for an ASA. When use, remember, it's a device that includes many services, and that is one of those services. Firewall. So we said it's a firewall, it's an intrusion prevention, it's an advanced malware, it's an IPsec that can connect site to site or a remote user to a site. And here we're talking about a firewall. Okay. So the ASA, one thing that is very, very useful to remember, please remember this, is it's not running the Cisco iOS operating system. Up until now, we have been using the Cisco iOS with the switches and with the routers. And ASA does not use the Cisco iOS operating system. It has its own operating system. So ASA has its own operating system. The good news is it's very similar from an end user point of view to an iOS. So you will see a lot of the familiar commands we've been using all along. And at the same time, it's different. So it's similar, but it's not iOS. Don't expect all of your iOS commands to work. Don't expect the syntax to be the same. But it's not that much different. Okay. Okay, we do have a version, and remember, it's not iOS, so it's going to be a different version. Okay. I am trying to get, all right. So host name, we're familiar with it. Domain name, we're familiar with it. Enable password, we're familiar with it. Banner, message of the day. Okay, so there's nothing really new here. So the basic configurations are the same basic configurations we learned before. Okay. Configuring the VLANs, and we have to do that. So the inside is a VLAN, the outside is a VLAN, the DMZ is a VLAN. The inside can be multiple VLANs, not just one VLAN. So you can have one or multiple VLANs on the inside. And the commands are similar, not exactly the same, are similar. However, if you understand DHCP, you understand DHCP. The fact that the syntax is slightly different, who cares? It's DHCP. And if you understand NAT, you understand NAT. The fact that the syntax is slightly different, who cares? So you have a template, you put all these commands in your template, and that is your template. That's where you go to find out exactly what the correct syntax is. But DHCP is DHCP, NAT is NAT, VLAN is VLAN. So none of that stuff is different with ASA. The only thing that is different is the syntax is going to be a little different because it's not iOS, it's ASA operating system. Okay, interface, VLAN, name, IF. This is new, for example, name the interface. This is what IF stands for, and we're calling it inside. And then from that point on, we use the name inside to refer to this interface. And outside, from that point on, you refer to the outside to refer to that interface. And you will see these in the labs as we get into the labs. So we have these 8 Ethernet interfaces, E for Ethernet 0001. And you can have as many of them as you want for the inside, the outside, the DMZ. Usually it's just one for the outside. Usually it's just one for the DMZ if you want to have a DMZ. And you're left with 6 that you can use for the inside. And the inside can be a single VLAN 1, and then you associate these 6 different Ethernet interfaces with VLAN 1, or you can have VLAN 1, 2, 3, 4, 5, whatever you want. Okay. And show switch VLAN, everybody, again, the syntax is different. And here it's showing you have a VLAN 1 and 2, inside and outside. And these are the ports that are associated with the inside and the outside. And almost always 00 is the outside. Nothing new, nothing new. And nothing new, right, everybody? NTP, we've covered NTP before. The syntax may be slightly different, but NTP is NTP. It doesn't work any differently. DHCP is DHCP. It doesn't work any differently. And I'm going to stop here. Okay, so let's do some labs. Before we do labs, any questions? We're good? So let me check this really quick. 61. Okay. And we are at 42. All right. So let's do a lab and then we'll come back. We don't really have much for chapter 11 in terms of labs. We have few things that I will demo along the way, but we don't really have any labs. Chapter 9, let's stay here. This is a really great video, everybody. So 9.1.1.2. So I would highly recommend that you watch it when you go over the Net Academy material. So let's do lab 2. And you will see a lot of what we talked about already. And let me get this out of the way. Okay. So the green is the inside, pink is the outside. We have an ASA device, ASA 5505, and I want to show you where they are, everybody, right here. You can see them, 5505, 5506. So when you're building your packet tracer labs, this is where you need to go to find and this is the icon that Cisco uses for ASA. And then we have an ISP. So this is our ISP router that connects us to the outside. Okay. So before we start, ASA does not use the Cisco iOS operating system. ASA has its own OS, which is similar to iOS and different. And just to show you one difference, if you are using a Cisco router, like the ISP router, it's just a Cisco router. Let me see, it is a 1941 router. Then you will just type erase, start, and reload. This is what we have done up until this point. On ASA, you will have to do write, erase, and then reload. So it's just a different syntax. Both of them will do exactly the same. And using iOS, we've been doing write or do write instead of copy running configuration to startup configuration. Well, write does not work on ASA. You have to do the copy running configuration to startup configuration to save your changes. So let's configure the ISP router. And all I am doing, I'm just configuring those two local area networks. So if you were to look at the ISP router, we have one local area network on the right, and we have one on the left that connects to the ASA device, and I'm configuring it. And down below, I have a gateway of last resort that is pointing at the ASA router. So we only have two routers, and each of them is a gateway of last resort for the other router, which means we can easily get into a ping pong game, but we will avoid that. So I'm gonna copy and paste. There's nothing new here. We've done this a gazillion times. Cont and paste. We've configured that. So let's move down to the ASA router. Okay. So host ASA1. Okay. Enable password. So far, so good. Nothing new. So let's go ahead and configure interface VLAN1. Okay. This is the IP address. And the next two lines are new. So name IF. We are naming the interface, and I'm calling it inside. And this is what Cisco recommends. And security level is 100, which is the highest security level, which means I can go anywhere, but they can't come back in without an ACL. And then interface Ethernet 01 is a part of VLAN1, and interface E02 is a part of VLAN1. Good, everybody? So I'm using two ports for inside devices, and I'm putting all of them on VLAN1, which means I only have one VLAN, and it's VLAN1. And if you were to look at the security level, it's 100. and then interface 00, okay, and that is VLAN 2. And VLAN 2 is the outside right here. So I configured VLAN 2, I gave it an IP address, name IF outside, security level 0, which is the lowest. 100 is the highest, 0 is the lowest, which means I can go from green to pink, but I cannot go from pink to green without an ACL. Any questions on the basic configurations? And then, of course, I configured a gateway of last resort, which points to ISP. So let's copy and paste. So definitely some new skills here. It's different. It's a different operating system. And you notice it's asking for a password, even though we haven't configured the password. So hit enter. So you have to remember to do this. So when you take an ASA device out, it's going to prompt you for a password. You don't have a password, just hit enter. That's the password. And Cont, and I'm going to paste. And then if you want to do showrun, you can type showrun from anywhere you want. If you remember, before with iOS, we can only do showrun from a certain mode. With ASAs, I said this is silly. You should be able to do showrun from anywhere, or show. You should be able to use the show command. And you can use the show command from wherever you are. You don't need to do. So I'm going to type showrun. And this is all we have configured, which is not really much. Okay, so you can see I have VLAN 1 configuration. I have VLAN 2 configuration. I have a gateway of last resort. And I've attached interface 00 to VLAN 2. And everything else is attached to VLAN 1 by default. Okay. So different. Before we would do show IP interface brief. Do you guys remember that here on ISP router? Okay, I'm gonna have to do show IP interface brief. If you want to do the equivalent thing at ASA, you don't really need to do. And then it's interface IP brief. So the syntax is slightly different, but no big deal. It's just syntax. And as long as you remember that this is not the iOS operating system and the syntax is different. And then finally is show switched VLAN. Show switched VLAN. And here they are. We have we configure 2 VLANs, 1, 2, inside, outside. And these are the ports that are attached to each of these 2 VLANs. And we only have 1 port for the outside, 0, 0. So let me ask you a question. So green is 100, pink is 0. What can we currently do?
Green can go to pink without needing any special ACL.
Very good. And continue that statement for me, Joey.
Pink has to follow ACL rules to get into green.
And pink can't. We haven't created any ACLs, right, everybody? So green can go to pink, pink cannot go to green, because 100 can go to 0, 0 can go. Very good. So if I was to ping 8888, which is in pink, from the inside, is it going to work? What do you guys think?
If you're pinging 888, the server 2 there from the green side, that should work.
Very good. So let's talk about that for a second. So absolutely, we should be able to get to the outside and hit 8888, and then coming back, everybody coming back, we're going to hit the firewall.
So the IMCP or the reply request will get blocked, and we won't know that it actually worked.
You got it. And we have to do something to enable that to happen. And I want to show you just to be safe. So let me first ping it, and then we can see where we're hitting the wall. So ping, or any service, FTP, HTTP, it's really the same. Okay. And I'm going to go into simulation, and I'm going to try it again. And let's see what happens. So we went to ASA. ASA said from 100 to 0, no problem, go for it. It went to 8. Now it's coming back from 0 to 100. Cool, everybody? It's like, I don't really have any ACLs in here. There's nothing in my configuration that says allow traffic from pink, and you can see, you know, a red X. And just to do one more, and if I was to ping from pink to green, 200.1.1.2, let me see, what is it? Yep. And this is also going to fail, but we're not even going to go through the ASA device because we're going from 0 to 100. We're going to hit a wall right away. And if I was to simulate, and you can see that, and you're going to see the X, the red X. Good, everybody? So we need to do something. So let's talk about that. So let's scroll down. Okay. So we need to configure the SA to allow ICMP, DNS, HTTP traffic initiated from the inside, which we call a stateful firewall, except it's not an open-ended stateful firewall. We're limiting it. We're limiting it to specific protocols. So we're saying, if I initiated an ICMP from the inside, allow it back in. If I initiated a DNS, allow it back in. If I initiated an HTTP, allow it back in, and don't allow anything else back in, even though it was initiated from the inside. Okay, so the syntax is going to be different here, and we're going to be covering this toward the end of the slides. So I want to talk about it for a few minutes, and then we'll come back to it later on. So we're going to have to create a class map, and then a policy, and then we have to attach the policy to an interface, just like we did with an ACL. This is an ACL, everybody, using objects. This is an object-oriented ACL. And let's take a minute and talk about objects, and then we'll come back and we will dissect this in a little bit more detail. So what is the benefit of an object? Let me ask you, if it's object-oriented programming, or if you're using objects with a directory service. If you remember when we talked about directory services, we said everything is an object. The computer is an object, the group is an object, the account is an object, etc. So what benefit does object give you? Have you guys taken 161? And I think, you know, 161 is required. Did you do some object-oriented programming in 161?
At OSU, they do, and I know that it's covered a little. I'm pretty sure it's covered a little bit in LB's class because I talked to a couple of guys and they know about it.
So what's the benefit? What is the benefit of object-oriented? Anything?
Well,
objects can have multiple attributes.
Say it again.
Objects can have multiple attributes.
Okay, objects can have multiple attributes. Very good. What else?
It simplifies. It's containerized, so you have one thing and it's doing that one thing.
Okay, very good, very good, very good. You're getting close. What else? You can reuse that object over and over and over again, right? Everybody, you create the object once, and you can start 100 instances of that object, right? Everybody, that's really the main point of object-oriented programming, is you create the object once and you can use it in as many places as you want. And let me give you a better example, everybody, an example that we can all relate to. So when we talked about directory services, when we talked about Active Directory, and we talked about objects, because everything is an object in Active Directory, and you create a group, and let's call this group help desk, and you put 10 people, because currently there are 10 people in that team. And then you push that group to 1,000 computers with everybody. So now you have 1,000 computers out there using this help desk group object. And one of those people quit. Do you have to touch those 1,000 computers, or do you modify the object and you're done? And the short answer is, you know, you remove the person that left the team from the help desk group and you're done. And that object is being used by 1,000 computers. And then you hire 2 new people, and then you add them to the group, which is an object, and you're done. You don't really have to do anything with those 1,000 computers out there that are using that object. So this is the beauty of object-oriented anything. And here, you know, we're extending it to ACLs. So we're saying, you know, we want to have objects in an ACL so I can reuse it over and over again. All right, so we create a map, we create a policy, and then we have to attach that policy to an interface. If you guys remember when we created ACLs, we always had to attach it to an interface, incoming or outgoing. Well, it's the same thing here, except with ASAs, they're saying if you want, it can be a global, which means all interfaces. You don't have to go and say, and attach this to interface 0 and 1 and 2 and 3 and 4 and 5. I want to use it globally. So let's take a closer look at it. At this, remember, you can type a command from anywhere. So I'm going to type class map question mark, and it's just a name. So this inspection underscore default is just a name. You can call it XYZ. In fact, I want to call it XYZ. Okay. And then match question mark. Okay. And it's saying, what would you like to match? Would you like to match an access list you created? Do you want it to match any, which is any? I don't care. It's good. Or do you want to use this default inspection traffic? And the default inspection traffic only allows this specific traffic. So in here, you can see we have FTP, TCP 21, we have HTTP 80, we have DNS 53, we have ICMP. Cool, everybody. One thing you're not going to see in here is HTTPS. But you know, it's a default. It's a default class, and the default class covers all of this. And I'm going to come back here, and I'm going to say, yeah, I want to use the default class for now. So match default inspection default. Good, everybody? Match inspection default. Inspection. How about traffic? How about default inspection? How about if I spell it right? Will it fill it out for me? Thank you very much. Okay. Good, everybody, and exit. That's it. This is all we've done so far. So if I was to type show run and look for it, this is it. I've created a map called XYZ, and it's going to match that long list of default permissions. Okay, and now we need to create a policy map. So I'm going to type policy question mark, and it is just a name ABC. Okay, and those are horrible names, but they're short and easy to remember. Okay, and now I want to do class question mark. And the class is, what class are you using? And I'm using the XYZ class, right, everybody? The one that I created, this one right here. So class XYZ. Okay. And then out of that long list, do you want to allow everything, or do you want to be more specific? And I'm saying, no, I want to be more specific. I don't want to allow all that stuff. I only want to allow ICMP, DNS, HTTP. Good, everybody, from that long list that you saw earlier on. So it's, now you say inspect. And I hope you remember inspect. Inspect is a command we used earlier when we were talking about firewalls. And this is basically how to create a stateful ACL, saying if it initiated from the inside, allow it back in. And this is exactly what we're doing here. And now I'm going to do inspect, ICMP, inspect, DNS, and inspect HTTP. So that's all I'm allowing. I'm not allowing FTP. I'm not allowing any other of these default services, and exit. And now if I was to do show run, and here they are, okay, class map XYZ, policy map, okay, ABC, and I'm allowing DNS, HTTP, and ICMP. And then the last thing I need to do is I need to map it to an interface. And let me show you. Okay, service policy, and we called it ABC, right, everybody? And it's saying, do you want a global or do you want a specific interface? Do you want it to work globally inside of ASA, or are you only interested in a specific? And this is what that global is. And now I'm going to type global And now if I was to do show run, you can see the whole thing, because you're going to see this over and over again. And I wanted to dissect it a little bit. And I picked XYZ and ABC just to get away from these long names, because they're just a name. Any questions here? Now let's go back and test. Okay, so now I'm going to come to PC0 and I'm going to ping 888. Remember, before we were able to go from green to pink, but we weren't able to come back, okay, like a classless firewall. And that inspect command makes it class full. Means if it was initiated from the inside, create an ACL for it and let it come back and ping 888. And now it's working. And FTP, because we didn't allow FTP. Do you guys remember? I'm going to come back here. Okay, we only enabled DNS, HTTP, and ICMP. So that's going to fail. We're going to be able to go from green to pink, but we don't have an inspect command to allow FTP back in. So that failed. But we can do DNS, which is NS lookup. And DNS works, and we can do HTTP because we allowed HTTP as well. 8888. However, HTTPS is going to fail because we didn't allow HTTPS. HTTPS 8888, and that's going to fail. Are we good? Does that make sense?
I believe so, yeah.
Okay. How about the rest of you? So don't let, all these long names scare you. There's nothing scary here. We're just using an object-oriented ACL, if you like. And it has lots of advantages. Now we've created ABC, now we've created XYZ. We can reuse it over and over again. Okay.
For your example, when you typed it in, you changed the name of the class map to XYZ, and then
I just wanted to make it easier, Joey. That's all, because inspection underscore default. It's a meaningful name, but it's a long name.
Okay, I think I might have missed the underscore on the default. I was wondering if creating the class and the map named the same thing, would that cause any conflict?
Oh, like class map inspection default and policy map inspection default.
Class below that, but I'm probably not understanding
yes,
part.
Yes, they have to match. Exactly. The class is the class. You see, it's saying over here class map, and then down here class. So we have to use a defined class. If you were to type in class Zico, it's going to fail because it says I can't find class Zico. Did they answer your question?
Yes, thank you.
Okay, good. Yep, absolutely they have. And down here it's the same. Service policy, global policy has to match this global policy. Otherwise, it's going to fail. The command is going to fail because it's going to say there is no global policy. So these names have to match. And if you're typing them, it's a bit of a challenge. But if you have them inside a file, like I do, it's you copy and you paste, and you're good. So go ahead, Frank.
I might have missed this. It seems like we would have to add in every case that we're looking for as far as allowing the traffic through. Is there?
Yes, I'm one step ahead of you. Remember the any? Remember
yes, that's where I was going. Thank you.
So any is any. So let me show you, everybody. Okay. So I'm going to do class map. It was XYZ, right? And then we said match. Do you remember this? Okay. So you can use any and you're good. So you can specify a specific ACL to do whatever that ACL does. You can be as broad as possible with any, or you can use this default, which is something in between. And that's what I did. And then I said, I don't really want to use all of the default. I just want some of the default. And I narrowed it down.
Okay. I think between working on the packet tracer myself, I think I missed that part.
It's quite okay. It's quite okay. This is why we're doing this. Okay, so we will come back to this, and then in the next lab we'll add an ACL, and then you'll see how it works with ACL, because I want to be able to go both ways. Are we good? So let's do another lab that's going to sit in the top of this lab. So let's move down to 3. I want to allow some outside traffic in. Remember the first lab, we allowed some of the internally initiated traffic back in. With everybody? So that was lab number 1. Allow some of the traffic we initiated in the inside zone back in. And now I want to go both ways. And it's the same topology. I think I added another server in the ping. So the ISP configurations are the same. So let me copy and paste, get that out of the way. And then the basic ASA configurations are the same: host ASA1, enable password, VLAN 1. These are the interfaces that belong to it. VLAN 2, this is the interface that belongs to it. And last time we went as far as step 3, which is the gateway of last resort. Good, everybody? So this is what we did before. So up until step 4, there's absolutely nothing new. And then I added an ACL. And I'm using an extended named ACL. Okay, so I'm saying access list from internet. It's a named ACL. This is just a name. You can call it XYZ, ABC, whatever you want. But from internet makes sense. It's extended. Permit TCP host equal www. So I'm allowing 888 from the inside to talk to 200.115 in the inside, and only for port 80. And this is how you make those firewall holes small, everybody. Because if I was to say any 80, well, now that's a big hole into your firewall. You're saying from wherever you come, wherever you want to go, and at least you specified port 80. Worst case scenario is permit IP any. And it's like, okay, the gates are wide open. So one extreme is permit IP any. Everything's allowed to deny IP any. Nothing's allowed. Those are the extremes, or something in between. And the more specific you are, the smaller the hole you're drilling into the firewall. And this is a pretty small hole, everybody, because I'm saying TCP, and I'm saying from this host to this host using this protocol. And that's good. This is a very, very good rule, because it's very, very specific. And the more specific, the better, the smaller the hole. So you can see what I'm allowing. And then I have to apply this ACL to an interface. And if you remember with ASA, we named the interfaces. So what we had done before is say, FA01 or gig00. Well, here we have to use the name. And I'm saying interface outside. And if I was to scroll back up, okay, interface VLAN 2, name IF outside. So this is the interface that connects me to the ISP. I don't think there's anything new with the ACL, except we're using a name for an interface instead of gig00 or FA01. That's the only difference. The rest of it is all familiar. And I hope the difference is minor. Who cares? We're using a name instead of an interface. Any questions?
No, that seems that it just works the same way it does with VLANs or any other like actual interface you're using. It's virtualized just like anything else.
Yep. So let's copy and paste. So the only difference between this exercise and the previous exercise is I created an ACL and I'm allowing some ping traffic in, very specific. So I'm going to copy and paste to ASA. Remember the password. I don't have a password, so hit enter. Conf T. I remember the very first time I worked with an ASA, that was a waste of half an hour trying to figure out what the default password is until I realized it's enter. That's the default password. Because I thought they had a default password like so many routers do. And I was looking for it and I couldn't find it. And then I can do a show run. And the only thing different that we're going to see here is the ACL. This is the ACL that we created and we applied to the outside interface. And now let's test everybody. Okay, so I'm going to leave them sitting next to each other so you can see what is allowed and what's not allowed. Because we're not allowing very much. We're being very specific. And I'm saying from 8888, I can ping 2000.115. So let me do it. Ping 115. And it's going to fail the first time like it always does, and then it's going to work. Maybe it's going to fail 2 times. Let's see what we did. From, oh, everybody allow www. I didn't mean to do this, but I'm glad I did this. Good, everybody? This is the beauty of being very specific. And what was I doing? I was pinging, right, everybody? Well, I didn't enable ping, sorry, from here. So let's do HTTP 200.1.1.5. Did you guys get that? Okay, you see it says www, and I was doing a ping. Well, the ping failed, but the www worked. And now if I was to try and do www to a different device, to server 2, and server 2 is 115, from here, it's going to fail because I don't have an ACL rule for that. I only have 3 rules and they are very specific. Okay, and that's the only thing that's going to work. But it's going to work. And if I move down to FTP and to 112, so now I can FTP FTP 200.1.1.2, and that worked because I have a rule that allows that. However, if I was to FTP to 5, that's going to fail because I don't have a rule that allows 8888 to go to 1.5. And then the last thing is I can ping from 82 to 15. I can go back to 82, and from here I can ping 200.1.1.5. So please remember, we're going from 0 to 100. And the default is not, you can't, except I create an ACL, and the ACL said allow the following, but nothing else. And that's all I can do from pink to green to override the default of nothing is allowed from a lower number to a higher number. So you can do anything you want. You're the system administrator. You just have to know this is the default, and this is how I override the default. Are we good? So let me ask you a question. So based on the configuration we've done so far, and let me show you. Show run. Okay. Do you think I can ping from green to pink?
Yeah, you should be able to because we've allowed ICMP.
Okay, where did we allow ICMP? We allowed it from pink to green. This is, we created this ACL, Frank, and I applied it to the outside interface. I applied it to this interface right here. And this is only from here to here, from to.
Oh, I thought we added the ICMP on the outside.
Here, I haven't applied it yet.
Oh, okay.
Okay, so right now it's gonna fail, and I wanna show you it's going to fail because we haven't applied that inspect ICMP. Ping 8888, and it's gonna get there, but it's gonna hit the wall in the way back. And this is the beauty of packet tracer, is you can see exactly which wall you're hitting. And these are the same exact configurations I did before to allow ICMP, all DNS, all HTTP, exactly the same. And now I'm gonna, and the order doesn't matter. The order doesn't really matter. So you can do it before, you can do it after, it doesn't really matter. And now show run. And you can see the ACL we created, and you can see the policy. You can see the policy we created for the inside data. And now to come back to server 1, and now it's gonna work. And we are specifically focusing here on the firewall aspects of ASA. IPS would work like IPS does. Advanced malware protection would work like, you know, any anti-malware would work. So I'm not focusing on these because the firewall is different here. And I want to focus on that and IPsec. Questions? Are we good? Okay, you have access to those labs, and I know they will make more sense when you do them on your own, at your own speed. So let's go over a few more slides, and we'll come back and do one more lab. I only have 4 labs, and I want to save the IPsec lab for Thursday. So Thursday I will do a review, and then we'll do the IPsec. And last week we spent a lot of time with IPsec, and I know if I show you this one slide, you will remember, was it in here? GIF, IPsec. Nope, those are the steps. Those are the steps. GIF. Slides. Do you guys remember this slide? This is your 5,000 foot level slide of IPsec. We spent some quality time with this last week for a good reason. And of course, ASA supports IPsec. And I want to show you how we can do site-to-site using ASA, which is a very, very super popular security appliance to support firewall, intrusion prevention, anti-malware, and IPsec for site-to-site or individual user to a site. Okay. So we talked about objects, right, everybody? We said, you know, what's the advantage of objects is created once and use it as many times as you want. And you can embed objects in another object. That's another advantage. So to go back to Active Directory, you can create a group and you can have another group, 2 groups, 2 objects, and you can put one group in another group, right, everybody? We can have the help desk group inside the administrators group. So we're embedding objects inside other objects, and that's an advantage. Okay. So we're doing objects for ACL. Instead of the traditional ACL, we're using objects, and we can embed them, and we can reuse them over and over. This is all there is here, everybody. So this is ACLs, like we've done ACLs before, except we are using objects. Excuse me, everybody, my dog is going nuts. 10 seconds. You're okay, Ms. Karuna? Okay, hold on. All right. So this is all there is here. Okay. Object groups. So we're talking about objects. We're creating groups using objects. It gives us the advantage of build it when, use it many times. It gives us the advantage of embedding objects inside another object, which is great, which is cool. So if you have 5 ACLs, everybody, you can put all of them inside another object. And now you have an ACL that encompasses all the capabilities in these 5 different ACLs. And they are telling us we can use objects with networks, services, security, the different ICMP type, echo reply, all these different ICMP type protocols and users. And I think I want to stop. I'm going to leave this till Thursday, everybody. What's next? And then they have a bunch of examples on how to use them. And if I'm flying ACLs, we just finished talking about ACLs, except now we want to use ACLs with objects. And I really want to stop. I want to go back to my third lab. Let's save this till Thursday. So let's do another lab. So let's add DHCP and NAT. So I'm telling you right now, the syntax is different, but we all know how DHCP works. And we all know how NAT works. And that's the important part. If you know how a service works, who cares? You know, the syntax is different. You can just look it up. You can Google it. You can save it in a file. You can copy and paste it. That is super easy to do. The harder thing is to understand, you know, what is DHCP? How does it work for v4? How does it work for v6? And what is NAT? Which flavor of NAT are we using? How does it work? So that's the important part. So let's do 4 and 4. And we're using the same topology. So this is the same packet tracer lab. Okay. So we're going to enable DHCP. We're going to enable NAT, allow inside traffic out and some back in through the ASA router. So the ISP configuration is exactly the same. So I'm just going to copy and paste. And we'll stop where things are different. And then I'm going to allow ICMP, DNS, and HTTP traffic initiated from the inside back in. Okay, we've gone over this twice before. Where you do it, it doesn't matter. So before we did it at the end, now we're doing it in the very beginning. It doesn't matter. So I'm going to paste it here on ASA. And now if I was to do show run, that's all there is. Okay, don't really have anything else yet. And then I'm going to configure the basic ASA configurations, you know, the inside, outside, don't have a DMZ, and DHCP and NAT. So the step 1 we've done before, it's just to give it a name and a password. Step 2 we've done before, we're giving the ASA interfaces IPs and names. Okay, step 3 we've done before. This is our gateway of last resort. And step 4 and 5 are new. So let's take a look at step 4 and 5. So step 4 is DHCP, and we want to, along with IP and subnet mask and default gateway, we also want to give a DNS IP. And this is the syntax, everybody. Okay. So D is for daemon, DHCPD, DHCP daemon. Daemon is a process. Okay, anything from 5 to 10 on the inside. So this is the interface name. So we're applying it only in the inside. Okay, and then we have a DNS IP also on the inside. Okay, and I'm enabling DHCP on the inside. So the inside is Ethernet 01 and Ethernet 02, because both of them are in VLAN 1, and both of them are associated with the inside. So it's not really that much different. It's different syntax, but it's not that much different. Okay, so I'm saying when I'm dishing out IP addresses, start with 172.168.1.5 and go all the way to 10, and then, you know, use my subnet mask as a subnet mask. and use my IP as a default gateway or a router IP, and then use this DNS IP. And then for NAT, everybody, object, back to objects, okay. Network inside LAN, this is just a name. You can call it XYZ, ABC, it doesn't really matter. And then I'm using it with this subnet, 172.168.10, and this is the green subnet. Everything in green is in 172.168.10. We only have a single VLAN. And then NAT inside going out. So we want to NAT, we want to give the internal devices a NAT IP when they're going to the outside. And the IP they are going to inherit is the outside IP address, right? Everybody, just like when you leave your house and you're using NAT, you're using your one and only public IP. And this is the IP that your ISP gave to your wireless access point. Okay, syntax is different, but there's nothing new about DHCP or NAT. So let's copy and paste from here down. Show run. And we can see the DHCP configuration, and we can see the DNS configuration, the NAT. This is NAT right here, everybody. Okay, and the rest of it we've seen before. Very good. So let's go back. Remember, we've enabled ICMP traffic to come back into green. We've enabled DNS traffic and HTTP traffic to come back from the outside in. Okay, we haven't enabled anything from pink. We didn't create an ACL like we did in the previous lab to allow any pink data into green. So no pink initiated data, outside initiated data is allowed inside. So let's go ahead and I will emulate and show you what happens. First, we have to give PC1 and PC2 IPs, everybody. So I'm gonna, because we want to use DHCP. And 1.5, if you remember, 1.5 was the very first IP. DHCP is going to dish out, and we do have a DNS IP. And then PC2 will be 1.6. And the servers have static IPs, so we're good. And now if I was to ping 888 or 8882, it's going to work. Because we allowed ICMP data back in. Here we go. And I can ping 88, and that will work. And I can go over here, and I can do an S lookup server 2. Yep, okay. Let me see what does the DNS server support. So this is the DNS server, services, DNS, Zico, okay. Zico, that works. We can HTTP, that's gonna work. 8882. And FTP and HTTPS would fail because we're not allowing that traffic back in. And let me simulate, and let me show you what's happening if I was to ping 88, and let's follow it. And now we're at the ASA device. Let's see what's coming in. Okay, the source is 172.168.111. Okay, and the outbound, the source is 203.112, and 203.112 is the IP address for the outside interface. Okay, and now we're gonna go all the way to wherever we were going to, 8888, and come back. And let's take a closer look. Okay, and destination is 2003.112, which is the ASA outside interface. And now we're at the ASA device. What is going to be leaving the ASA device? Destination 172.168.111. This is NAT. There is absolutely nothing new here. This is NAT. I'm just showing you can use NAT with ASA, because if this is your one and only device, everybody. So if you're a small company, a branch office, this is it. This is your one and only network device. You need the DHCP. Well, it can do that for you. And you need a NAT because you only have one public IP that everybody inside that branch, small office is using. Okay, very good. ASA can do that for you. No big deal, nothing new. You know, this is your one and only network device. Over and above doing security, you needed to do DHCP and NAT. And that's what we did here. Questions? Are you becoming comfortable with ASA? We haven't covered IPsec. We will on Thursday. But from what we have covered today.
I think so, yeah.
Okay.
It's one of those things, just getting familiar with it more and more, just typing the
Okay.
commands in the interface.
Yep. It is a super popular product. ASA in its many different variations, you know, from 150 megabit to, you know, 10 gigabit, very, very, very popular. And the smaller the company, the more likely is this is it. That's it. Is they just have this one ASA device and it does 15 different things for them. And if you're a medium size, then you most likely have a router, a dedicated router that connects you to your ISP. And ASA is sitting immediately behind it. This is the very next device that that router connects to. And it is inline. Everything flows through it. And you don't want it to become a bottleneck. And it provides you with all these different security services that traditionally different products provided, except now you're putting it all into this one device. It does firewall, intrusion prevention, anti-malware, advanced firewall, advanced inspection, advanced anti-malware. And of course, you know, it can do NAT and DHCP. But it's not going to be enough. It's just a device. It is a layer. Remember the layered approach? It is a layer and you're protecting your perimeter, which is where protection should start, right, everybody? It should start before you get into the house, before you get into the enterprise. This is what it's defending. And then it's saying, okay, you guys in the inside, you still have your own protections, but I'm going to do my best to protect you from the internet, from the outside. And if anything slips by me, hopefully some other layer will catch it. Maybe chapter 6, do you guys remember chapter 6? We talked about LAN security, port security, etc. So you still need those other layers to do their job, but I will do what I can at layer 3, 4, and above to protect you. Any questions from what we've covered today? Go ahead.
Yeah, I've just got a side question on the ASA modules. I've looked through a couple of the two that are in Packet Tracer, and I've tried to configure them. Do none of them come with a fiber interface since they're connecting to the ISP?
Yeah, very good. The higher end ones do, but not the, remember the 5505 and the 5506 are the low end.
Yeah, and that's where it's...
And one more thing, remember, you know, if you're a medium size to a larger size company, you have a dedicated router that connects you to the ISP, and that will support fiber.
Okay, and then you split it up from there. Okay, I just wasn't sure. It's like I wasn't sure if that was like an option because I haven't found any.
I don't believe it's an option for 5505 or 6. Remember, this is low end. Yeah, but the higher end ones will. if you're a small company, you're not using fiber to connect anywhere. You're using Ethernet or Metro, maybe.
Okay.
So for those of you that have a job or are doing an internship somewhere, do you know if your company is using an ASA? So Bill, Joey, do you have an idea what ATI does?
Not specifically, but I assume that they do.
Okay, yeah, I'm quite confident they have something. I just don't know what. And ATI, it's a good sized company. It's not really a tiny sized company. And they wouldn't be using 5.5 or 5 or 6, but they could be using an ASA or an ASA-like. Anyone else knows? I know LBCC, they use a 5506 behind the router that connects them to our ISP. Any questions about today? We're not done. And this is the last chapter where we cover in-depth technical anything. Chapter 11 is just a wrapper. It's useful, but it's a wrapper, and we won't be talking about specifics. Nor do we have any packet tracer labs for it. Okay, if this is it, then let's call it a day. I will see you on Thursday, and we'll finish ASA on Thursday. You guys have a wonderful day, and we'll see you on Thursday.
Sounds good.
Okay, have a good day, everybody.
Thanks, Zika.
Zika?
Yes.
I have a quick question about the with the exams. I just want to make sure and double check that on Monday the 8th, it's the SBA for 153.
That's right.
And I have basically the entire day to finish it and give it to you by the end of the day, right?
That's true.
Okay. So I start the morning and then I can give it to you when I'm done with it.
You just email it to me.
Yep, just email it to you.
Yep.
Then on the 9th is the 285 SBA.
That's true.
And I have the same thing with that, but I have all day to finish that and email it to you.
Yep, you got it.
Okay. And then
Yep.
on Wednesday, the 10th, is the 153 exam, which then that begins at 12 o'clock for me. And I have 4 hours to do it.
It's very true, except it may start a little after noon because I have to configure it. Remember, the rest of the class have until noon.
Yep.
And then I have to configure it. But sure, let's say 12:15, 12:20, and then I'll give you 4 hours.
Yeah, and then it's the same thing on Thursday, the 11th, for 285 exam.
Yes, you got it. And I have a note. I have a yellow sticky right in front of me, Robert, with your name on it, and all the details you said.
Okay.
So every time I sit in this chair, I'm looking at that yellow sticky. So I haven't forgotten, but thank you for reminding me.
I just wanted to remind myself as well. I just like going over it and make sure.
Okay.
I'm a very cautious person.
Good. Cautious is good. Better safe than sorry, right?
Yep.
Yeah. So you're good.
Thank you, Zika.
You are most welcome.
Okay. See you tomorrow.